In this video, we will be learning about the disk scheduling algorithms. As you all know, disk scheduling is done by the operating system, and it helps in processing the I/O request which is arriving on the disk. So there are many parameters that is being used in order to determine the best disk scheduling algorithm. So one of them is seek time, and in this experiment we will be learning how to implement FCFS, CSCAN and SCAN scheduling algorithms. These three are coming under the disk scheduling algorithms, and how to compute or how to find the seek time for these algorithms we can learn. So starting with the FCFS, as you all know, we will be having a request array and it will be stored in the array, and you need to specify the head position also. So while processing the request, since it is a first come first serve disk scheduling, the order in which the request is being arrived, the same order it will be processed, or the addresses will be scanned by the disk. So there is no change. So how the elements are entered into the array, the same way you can give it for display and it shows the processing. And what you need to compute is the seek time. And how you will be able to compute means you need to take the differences between the positions. So that is from 50 to 82. The arm is moved from 50 to 82 in order to process the request stored in 82. So the difference you need to take 82 minus 50 plus, then from 82 where it is moving to 170. So 82 minus 170. Then from 170 to 43 it comes. So 170 minus 43. So this differences you need to take and take the summation of each differences. So to take the differences, how you can take is in taking the first case, the arm head is placed in 50. So inside the array you can push to the 0th index location the first arm head position, that is 50, and the rest of the elements it will be like 1, 2, like that it goes on. Okay, 5, 6 and 7. Then in order to find the difference, it will be like when you are scanning the first symbol, that is 82, it is in the location index 1. So you need to take the difference. So if the array name is A, means seek time you can take it, seek time should be like the sum of the differences. So you need to first take the difference between A of I minus A of I minus 1. Okay, 82 minus 50 you will be getting. You will be storing that value to some variable. Then again you need to compute the next scanning position will be this one, 2. So A of 2 minus 1, that is 82. So 170 minus 82, what is the answer you are getting? That plus the previous subtracted value you need to take. So this is how the computation will be done till it reaches to the end of the array in case of FCFS. Then next is related to the SCAN disk scheduling algorithm. In this also you will be having an array in which some addresses is being stored. First what you need to do is you need to similarly what you have done in the previous thing, that is in the previous one you have inserted to the 0th location the head value you have inserted. Similarly here also to the 0th location you need to insert the head value, that is 50. Okay, 50 will be inserted, and then in the 1th location you need to insert the left end of the disk, that is 0. You need to insert the left end of the disk, that is 0. Okay, then from the second location only you will be entering the values 82, 170, 43, like that it goes. So the length, while entering the elements into the processing the request into the array, not processing, while you are putting the request into the array, the length now n will be, what will be, n will be equal to, you have given n will be equal to 7, because you need to process 7 addresses. And when you insert this 50 and 0 into the array, what will be the length becomes? N will be equal to 7 plus 2, that is 9. Okay, in which 0th location will be having the head value and first location will be having the left end of the disk. Then you need to store the elements into the array like 80, 70, 170, 43, like that till 190 you will be entering the elements. So here you will be having the index location as 8. Okay, and towards the end, that is index location 9, you need to enter the right end of the disk. So if the size of the disk is 200, means the addresses will be like from 0 to 199. So the right end of the disk you need to insert like 199. Okay, so this is the way you will be inserting the elements into the array at first. Then after entering all these elements, you need to sort the array. So after sorting, you will be getting the request like this. With the modification, what you will be having 0 at first. Then in here you will be having 50. And towards the end you will be having 199. Okay, so this is the format you will be having. Then in order to perform this scan, it will be like another alternative name for this scan scheduling algorithm is elevator. So it will be processing either towards the higher order addresses or towards the lower order addresses. So in order to get the minimum seek time is in order to fix the best or the better this scheduling algorithm, one of the parameter was the seek time. So in order to minimize the seek time, one efficient method was like identify the lowest reachable address from the initial head position. So initial head position is 50 and the lowest reachable position is either it will be 43 or 82. So if you take the difference, what is minimum one? 43. So what in case of scan, here it moves to the lower addresses. Okay, processing, it moves to the lower addresses, processing the request that is arrived in the queue. Okay, so in this case, scan, it will be either moving to the lower addresses or it will be moving to the higher order addresses. You can implement as if the request should satisfy the higher order addresses, like that, assuming also you can implement the scan algorithm. So in the program that I am going to teach, in that I have just added one condition as if the minimum differences from the head position you will be taking. So minimum reachable address you will be taking, and in this case it is 43. So 43, then it will be moving to the lower order addresses, satisfying the request. So from 50 it satisfies 43, then 24, then 16, then the request is over here. With this 16, the request is being processed. But in case of scan, it moves to the end of the disk. Okay, first it moves to the end of the disk. So it is moving towards the lower end. So that's why it moves to the end, that is 0. And then after, once it reaches 0, it again moves to the higher order, higher addresses, that is while moving to the higher end, higher order addresses, what it does, it will be satisfying the request. So when it moves to the higher addresses, it finds that some requests are there to be processed. So it satisfies the request like 82, 140, 170 and 190. Here it doesn't move to the end because here it ends. The last, it stops in the last request. Okay, it doesn't move to the right end of the disk. It stops in the last request. Okay, so how you will be computing the seek time? So seek time can be computed as from 50 to 0. In a stretch it is going. So seek time will be like 50 minus 0. And then from 0 to 190. So seek time you can take it as 190 minus 0. Okay, so 50 you will be getting from the position, that is in which location 50 is being placed, you can identify. So for that you need to identify where the 50 is being placed. Okay, from the array you need to, after sorting, you need to find out in which index location the 50 is being placed. And then the lower bound, 0th value you need to take, you will be getting the difference. And then it moves to the upper, that is a higher request. So from the index you know that 190 will be placed in n minus 1th location. So n minus 1th location minus, so this will be an array A of n minus 1 location minus the starting A of 0. Okay, so by computing this you will be, then you need to take the addition of these two. It is 50 minus 0 and 190 minus 0. What will be the value obtained? That will be the seek time, and average will be like seek time minus the n value. It is what is the number of addresses that is being requested to process. Okay, so similar is the case with the CSCAN also. In CSCAN also the request will be first arranged in a sorting order. Add the elements 0 as well as 50 towards the array before sorting, and then towards the end you need to insert the last end, right end of the disk, that is 199. Based on the size of the disk it need to be inserted. Then in this CSCAN what it does, here also it will be checking for the minimum value. It can move either to the higher order addresses or to the lower addresses. So you can, in this it is assumed to be like it is moving to the higher addresses. Okay, so in such case what happens for higher addresses, you need to take the first seek time will be like seek time here it is made as 199. Why? While processing the request it stops here, that is 190. After from 50, 82, 140, 170, 190 will be processed, and after processing the request it need to return back in order to process the lower addresses. So for that it moves to the higher, that is towards the end of the disk it moves, that is 199, and then it moves back without processing any request. And then what it does, again it moves towards the higher addresses, processing the unprocessed request. So what will be the seek time? Here 50 to 199. So here you need to take 199 minus 50, and then what, 199 to 0. So 199 minus 0, and lastly from 0 to 50. So what is not 50, 0 to 43. 43 is the last request that will be processed. So 43 minus 0. So summing up you will be getting the seek time. and averaging